Hi, everyone. I'm Nicole, Senior Dev Advocate at the SDF. I'm super excited to introduce this new series, Learn Rust for Smart Contracts with Nicole, an absolute beginner's guide to Rust for smart contracts. In this series, we're going to build toward a larger application, a DAO, which I'll get into in a second, while covering one or two fundamentals per video related to Rust for smart contracts along the way. Full disclosure, I am currently learning Rust, so this is going to be as much my journey as yours. But this series is for anyone interested in getting started with Rust and or smart contracts, and anyone interested in building a DAO. So you don't need to have any Rust or smart contract experience whatsoever. If you're someone who is brand new to Rust, if you're someone who has never made a DAO on Soroban or anywhere else before, you will be in excellent company. And our main goal over the course of this video will be to build that DAO, a decentralized autonomous organization. But we're going to start from absolute scratch, setting up the environment and installing all of the necessary tools. As these videos go on, I'll walk you through connections I make along the way, fun facts I uncover, the challenges and frustrations I face as I work through this series. So hopefully, that kind of covers the things that you might find as you are embarking on this journey as well. And we're going to talk through some of the more conceptual ideas behind writing smart contracts, learning Rust, and building a DAO. But I'll try to strike a balance between that theory behind how these things work and things like syntax and kind of fundamental concepts and topics, and also the process of building a DAO with practical walkthroughs. So what is a DAO? A DAO is a self-governing organization that lets token holders or members participate in the management and decision-making through voting with no central authority. It's essentially that a community that might have a shared bank account and that votes on decisions to make and or how that bank account gets used with voting formulas customized as desired. We're going to get into that, but important to know for now, because this is my Rust for Smart Contracts series, and I want my own learning journey to be as fun as possible, we're going to create a specific DAO. It will be a membership-based DAO where members get to vote on their favorite cat videos, because when you can watch cat videos, you must watch cat videos. That is the rule. And of course, the name of our DAO will be MeowDAO. So let's get started building MeowDAO. To start building in Rust, we're going to need to set up our environment and make sure that we have the Rust and the Soroban SDK installed. So I'm going to link a few resources down below for your reference as we go through this process, including the Soroban docs, the Soroban SDK, and a few general Rust programming resources. So take a look at these at any point during the series. I'll try to make sure that any links that I reference or that I'm using throughout this process are all included with timestamps, so that at any point you can go back and reference those as needed. Sometimes, because this is going to be a Rust for Smart Contracts series, I'm not always going to cover every single Soroban topic in depth, but I'll definitely link to those resources so you can explore as much as possible. So to get started building MeowDAO, the very first thing that we're going to do is set up our environment. So we're going to start by installing Rust. If you've never installed anything before using the command line, it is definitely not as scary as it might seem. But we're going to navigate to the setup page of the Soroban docs. We're going to set up Soroban, and then we're going to kind of get things ready before we do a couple of things in pure Rust, and then come back to Soroban smart contracts. But of course, the first thing we need to do is install Rust. So I'm going to open up my terminal, and I'm going to just copy this Rust install. So going to click 1 to proceed, and Rust is installed now. Great, woohoo! While that's installed, let me say a few more things about Rust. This series is going to focus on Soroban Rust as not just a programming language, but as a smart contract language that is safe, fun to write, and helps you write efficient smart contracts, which is, of course, super important. In fact, Rust is an ideal smart contract language for a few reasons. One, it's type safe, which means that it helps prevent common programming errors by making sure that all types are consistent and correct. 2, Rust is memory safe, which means that it has numerous memory checks to prevent memory-related bugs. And 3, it generates small binaries. That is, the compiled executable files produced by the Rust compiler are typically smaller in size compared to equivalent programs compiled in other languages. The small size is thanks to Rust's lack of extra bloat like a garbage collector. So these three features, among others, make Rust ideal for smart contracts where correctness, safety, and efficiency are extremely important. I felt like that was an important thing that I learned as I was kind of starting this process. So I wanted to just call out a little bit of that history and kind of give a sense of why Soroban is built using Rust in the first place. So once we've installed Rust, we are going to add the WebAssembly or WASM compilation target. So WASM is a type of code that runs in modern browsers. Rust smart contract code essentially gets compiled down and converted into WebAssembly format before being integrated with the blockchain. So you can learn more about that, and we will talk more about that as well as this series goes on. But for now, all we're going to do is we're going to copy this target and we are going to paste it into our terminal. So we see that it's up to date. Woohoo! We can move on. We're then going to configure our editor. I'm using VS Code, and I'm going to link to this particular page in the show notes. But the most important thing is to make sure that when you have your VS Code open, navigate to the extensions, and you want to make sure that this Rust analyzer is installed. So actually, I should already have it installed. There we go. So I've already got mine installed. Just make sure that that's installed so that your editor is set up with this particular extension. Finally, we are going to install the Soroban CLI. And so in order to do that, we are going to copy this piece of code and run that in our terminal. The Soroban CLI or command line interface essentially allows us to run and deploy our smart contracts, which is obviously extremely important. So while that is running, we're just going to wait. Once that is done, we're going to create a new project in pure Rust, so not Soroban smart contracts to begin with. As I prepare each video in this series, I'm going to work across the Soroban docs and the kind of Rust programming docs. This is so I make sure that I capture the fundamentals of Rust for smart contracts while also making sure that we're getting the necessary context for learning Rust in general. So I'm going to do my best to direct us to and call out the most helpful pieces of information, but feel free to consult these pages at any time yourself. So to begin, we're going to create a new projects folder now that I see that the CLI has finished installing. So in order to create a new projects folder in our home directory, we are going to make sure that we have a projects folder. I already have one, but you can create one yourself if you don't. And then we're going to create a new folder for this exercise, which I'm going to call Hello Cats. So once we've got that, we are going to navigate into our Hello Cats folder. And here we're going to make a source file for the folder called main. Rust files always end with the .rs extension. And so once we've created that, we are going to open this file. And here it is open. I'm actually going to open the entire folder, Hello Cats. And yes, I do trust the authors. So once we've done that, we are going to navigate to our main.rs file, and we're going to write our first piece of code, and it's going to look something like this. I'm going to walk through it in 1 second. So super simple, couple lines of code. This is our first piece of Rust code that we have ever written. To kind of walk through each piece of the syntax here, our first line of code declares a function, fn, which we're calling main. This main function does not take any parameters. If it did, they would go inside the parentheses. Rust, like a lot of other programming languages requires curly brackets around all function bodies, which we see at the end of this first line. And inside those brackets is the body of our function. So println exclamation point calls a Rust macro, which is denoted by, the macro is denoted by this exclamation point. A macro is a little bit different from a normal function, but we're not really going to get into this right now. If you're curious to learn more, I'll include some links for extra resources about macros and the difference between macros and functions in the show notes. But the most important thing to note is that inside this macro, which is kind of the main body of our function, we have our string hello cats, which is the string that we're passing into the argument. Finally, the line ends with a semicolon, like most lines of Rust code and like many other programming languages. And that is it. That is our first ever piece of code in Rust. And so what we're going to do is we're going to now compile and run this code. And we're going to use the command rustc in order to run our code with the name of the file, main.rs. That compiles our program. And to run the file, this is in Mac, by the way. It's slightly different in Windows and other operating systems, but I will link resources for those commands in the show notes as well. To run the file, we're going to use /main, and we'll see that hello cats is printed out. We have successfully completed our first Rust program, compiled and run in the terminal. So that is kind of part one. I'm going to close out of this. That's part one of what we're going to do today. The second thing that we're going to do is we're going to write a program in Rust for smart contracts. So we're going to write actually our first smart contract. In the terminal, I am actually going to open a new shell. So in the terminal, we're going to create a new Rust library, and we're going to do this with the command line cargo new lib, and then we're going to add the name of our library. So I'm going to call mine MeowDAO, of course. So now I've got my library created, and we're going to navigate now to this library using the cd command. And once we're there, we're going to open the TOML file that has been created. So we're going to do that with open cargo.toml, and it actually did open, but let me do it again because I have too many other windows. So again, yes, I trust this author. And here's our TOML file, essentially. This one. Oops. Okay. I am having some issues with my VS Code being weird. Open cargo.toml. There we are. And we're going to open the entire folder for our MeowDAO library. In VS Code, now what we need to do essentially is configure a couple of things. We're going to configure the library type, we're going to import the Soroban SDK and features, and we're going to configure the release profile. So all of these things within this TOML file essentially set up the settings that we're going to need to build specifically for Soroban Rust. And so essentially all of this we can find here on the Soroban docs getting started page, which I will link to as well. So the things that we're going to need to copy are this library package. I'm actually going to copy them from off screen, but feel free to follow along with your own docs opened. So actually the package here with the name and version type are already included in our TOML file. What we're going to do then is configure the library type. Delete these. We're going to copy in this library type. We are going to import in a variety of dependencies, including the Soroban SDK and features. And then finally, we are going to configure the release profile. And this just makes sure that everything is set up correctly to work with Soroban when we start building our first Rust smart contract. So your TOML file should look something like this if you're following along. And that's essentially all we need to get started. And so once we've done this, we're going to write our first contract. So in order to do this, we're going to navigate to our lib.rs file. We can actually delete all of this for now. So the first line of code that we're going to write is essentially going to tell our program that we are not going to be using the Soroban SDK. So it's going to look something like this. Soroban smart contracts are written in Rust. However, there are several features of the Rust programming language that are either unavailable in the deployment guest environment or not recommended because their use would incur unacceptable costs at runtime. So for this reason, we can think of the Rust code written for smart contracts to be a kind of dialect of the Rust language. Soroban smart contracts add this no-std compiler indicator at the beginning of pieces of code in order to exclude the standard library and rely solely on the smaller underlying core library instead. The Rust standard library is very intensive, and this compiler indicator, no-std, helps optimize smart contracts, excluding the entire standard library that isn't relevant to Soroban smart contracts for the sake of brevity. But a lot of the standard library that is included in that Rust standard library is actually included in the Soroban SDK, which we're going to import at the beginning of this code, kind of in place of the standard library. So use Soroban _ SDK is going to import the Soroban SDK into our code. The Soroban SDK is essentially, it's still a standard library. It's just standard to Soroban, doing away with the bulk of the Rust standard library that's not relevant to building smart contracts. And this allows us to keep only the tailored functionality of data types and macros and logic that we're going to need to write our smart contracts. So once we've done that, we're going to write our next line, which is this attribute that indicates that code written here follows certain contract rules. We're then going to declare a public struct named contract. So pub here indicates that this struct is accessible and visible outside of this current module so that other parts of the code base can access it. Struct defines a new structure, which is a custom data type that holds multiple values of different types in a single data structure. And contract is the name that we've given to the struct. We're then going to add this contract impl attribute. This is not a standard attribute in Rust, but rather a Soroban attribute macro that exports the publicly accessible functions to Soroban. So I'm not going to kind of get into this, but if you are interested in learning more, I will include a link to this particular Soroban attribute below. Finally, we are then going to write we're going to define our public struct. So this defines the methods and functions for our struct using the impl keyword. This goes inside curly brackets. And inside those curly brackets, we'll have the methods and the functions that we need for our particular contract. And what we're going to put in there is a public function written with pub fn, and we're going to call this function hello. So we've seen pub before, we've seen fn before in our hello cats original function that we wrote. This pub fn declares a function called hello that has two parameters, which go inside parentheses. And those parameters are env of type n, env and 2 of type symbol. The env type here provides access to the environment that the contract is executing with. And so essentially every contract written with Soroban is going to take this env parameter. The symbol type here is basically a short string, and this is what we're going to pass into say hello to. So hello world, hello to world, hello to a friend, hello to cats eventually. And this is going to return a vector of type symbol inside these carets. A vector is like an array that can hold a collection of elements of the same type. So in this case, our vector's type is type symbol, which are here essentially just strings. Inside of our function, we are going to create and return a vector, and this vector is going to look like the following, which I'm going to try to write out correctly. There we go. So what we have here is a vector that gets returned, including 3 elements. So the first, ampersand env. The ampersand in front of the env parameter is the reference operator in Rust. So we're essentially taking a reference to the env parameter that we included in our pub hello function. I will include some additional resources for more information about this reference operator, but that's kind of all I'm going to say about it at the moment. The symbol underscore short exclamation point with our string is essentially a hard-coded string. So this is the thing that, says hello. And finally, our 2 parameter, this is the parameter that we're going to pass into the function when we invoke it in a second. So that is our smart contract code. We're going to test our smart contract before we build it and deploy it in a moment. And to do this, we're really just going to copy over some code from the Soroban docs, which I will link for you. So in order to do this, we're going to create a new file called test.rs. I'm going to copy in the test code that you can find on the Soroban docs Hello World setup page. I'm not going to walk through it at the moment, but we're going to add one more little piece of code now to the end of our smart contract, and we're going to run this test. And so that's going to run in our terminal. And as we wait for it, if you are interested to know more, I recommend taking a look at the Soroban docs to see, how this test is built. And we have our test results. We have passed our test. So everything is looking good. So from here, what we're going to do is we are going to navigate back to our terminal. And we're going to build our contract. And we're going to do this with the command Soroban contract build. And so once this contract has been built, we're going to deploy the contract using a command that locally deploys the contract to our WASM compilation target that we set up earlier. And so in order to do this, we're going to use the command Soroban contract deploy WASM target, and then I just tabbed and did a little fancy command here, but you can follow along what I've got with this command. We're then going to refer to our the name of the library that we built. So in my case, this is MeowDAO, and finally add .wasm at the end. Once I hit return, this is going to give me a public key, which I'm going to copy. Important to note, every time that you deploy a contract locally, this key is going to be different. So, and this key is going to be crucial to invoking our contract, which we're going to do right now. So once you copy that key, you are going to, or I'm going to, you may or may not be following along, you can invoke that contract with Soroban contract invoke, and then adding in the ID after, once we've referenced this ID, we're going to paste in the public key that we copied just before. And then I'm going to call our function hello, which we have over here, our public function hello. And I'm going to pass into that to parameter that we had referenced before, cats. So I am saying hello to cats. And we see that this returns our vector of type symbol, our symbol being our symbol being essentially strings here. So we see we get a hello cats. Congratulations, if you've been following along, not only have you written your first program in Rust, but you've also written and deployed your first smart contract on Soroban. And so have I, so this is great. But how does this fit in with our larger goal of building MeowDAO in Rust on Soroban? You might also be wondering where the cat videos are. Bear with me. What we've just accomplished is, in my opinion, a good chunk of learning a new programming language, getting things set up and successfully executing some code in that environment. So don't underestimate how significant that milestone is. And as a reward, here is a cat video. So to recap what we've covered so far, we've learned some of the basics of Rust code, how to declare a function, the syntax of curly brackets and semicolons, and we've also covered some of the high-level ideas behind Rust for smart contracts, including how to define a public struct for our contract, how to define functions that take parameters and return specific data types. In this case, those were specific to our Hello Cats very first function, but that's okay. But we've also learned what it takes to build, deploy, and invoke that smart contract via the terminal. So that's a lot. But to start building a DAO in earnest, we're going to need to take some next steps. In the next video, I'm going to cover the essential components of a DAO, like voting power, proposal modules, and treasury functionality, and outline what we'll need to do to get started building MeowDAO specifically. So stay tuned, and in the meantime, come join the Stellar Developers Discord. Thanks, everyone.